Hi guys, this is a video about the 5 types of chemical reactions. We're going to go over 2 right now, combination and decomposition. So let's take a look. Okay. All right, so there's 5, like I said. We're just going to go over the first 2 right now, and then we're going to move on. All right, so the first one is one called a combination or a synthesis reaction. There's 2 different types of terminology for it. Okay, so we're just going to look at that one first. And a combination reaction is a chemical change, okay, where matter is actually converted, in which 2 or more substances react to form a new single substance. So you're going to have 2 elements come together. All right, you're going to have a metal and a non-metal coming together to form a compound. All right, so you have your metal and your non-metal forming this compound. The electrons transfer from the metal to the non-metal. Okay, if you notice, the negative sign means non-metal, positive sign means metal. That's important to know. Now, some clues that I usually write on the board, but for today, we're just going to look at this. You start out with, in any combination reaction, you're going to have at least 2 reactants, okay? And then you're going to have a final single product. Now, element A from the formula that I gave you, A plus B, yields AB. A is going to consist of an element from group 1A, 2A, or 3A, and it's going to be a metal. Now, element B will generally be the non-metal, so it's going to have a negative charge. So let's take a look at some examples here. Now, the first example starts out with a group 1A metal, sodium, and it comes together to bond with chlorine gas. So what happens is the electrons from sodium are transferred to the chlorine gas. So it actually forms NaCl solid. So this sodium metal plus this chlorine gas forms this sodium chloride solid structure. All right. Then, you can go and balance this pretty easy. So you have 2 chlorines here, 1 chlorine there. So we're going to place a 2 right here. Okay, and a 2 right there. And then it becomes balanced. 2, 1, 2. So 2 sodiums, 2 chlorines on the left, 2 sodiums, 2 chlorines on the right. So this 2 goes to, remember, both those elements right there. If you have any questions on balancing, review my balancing video. Okay, example 2. You have A, which is your metal, and B, which is your non-metal. So together they're going to form MgO. Okay, so this is your compound, A, B. Okay, so you have your A plus your B forms your AB. Okay, and then you balance it. You place a 2 here, and you place a 2 there. Then it's balanced. Okay, example 3. We have our aluminum and our oxygen. Together, they're going to form an Al and an O. So it's going to form Al2O3. All right, so here's your A. Here is your B. And here is your AB. Now, the electrons had transferred from aluminum to oxygen, forming this compound. We're going to talk about that later. Okay, as far as this example here, this one doesn't have a group 1A, 2A, or 3A metal. It actually has a transition metal right here, iron. Okay, iron works the same as a 1A, 2A, 3A. Now, remember, iron is a transition metal because it has more than one charge. Iron also has another charge called iron 2. So there's an iron 2 and an iron 3. But that doesn't matter at this point. Okay, so together, these guys can come together and form your new compound. All right, so what you have here is your A, which is iron, your B, which is oxygen, forming your AB over here. your Fe2O3. Okay, then you have to balance this one. Okay, so we want to balance our oxygens first. I'm going to place a 2 here and a 3 here to make the oxygen satisfy. So we have 6 oxygen on the left, 6 oxygens on the right, and also we have 4 irons on the right, and now we have 4 irons on the left. Okay, so that's a little bit about combination, just putting them together. Okay, you're going to have 2 individual elements forming 1 compound on the right. Now, the second kind of reaction is called decomposition. These are very simple. These are the reverse of combination. Okay, so decomposition is a chemical change in which a single compound breaks down into 2 or more simpler products. So we start out with the final product. It's a metal plus a nonmetal. That breaks down to form your metal and nonmetal. Okay, so you have your compound right here forming one element plus another element. So the positive means here's your metal, and negative means here's your nonmetal. So it's going to form a metal and a nonmetal in this reaction. Okay, so some clues that you want to look for when you're looking at this for this kind of reaction is it has one reactant, a compound. It has 2 products. Element A is going to be usually an element from 1A to 3A. Also could be a transition metal. And B is normally going to be a nonmetal. Okay, so let's take a look here. Here we got to look at the decomposition. It's kind of out of the screen. Move this up a little bit. It won't move up. But it says decomposition of iron 3 oxide. So what you have here is your A, B breaking down to form your A plus B. So you have your compound on the left and your individual elements on the right. So this is actually the reverse reaction of one of the last ones we just did. Okay, so then you balance it. You put a 2 right here, okay, and a 3 right here to balance the O's. Then you place a 4 right here. Okay, it's reverse. Interesting. Now, this one here is called a decomposition of mercuric oxide. Ooh, interesting. Okay, now this is a pretty cool experiment. So you have, all right, in this test tube right here, of course you can't see with the pen, you have this reddish looking stuff. When I was in high school, we did this, but now you guys aren't allowed to be around mercury. So what you do is you heat up this substance. Okay, you see the mercury and the oxygen put together here, the silver mercury and the red oxygen. When you heat up this mixture, the oxygen leaves, goes away. Okay, a little red up here. Okay, then down here, silver. Then on the end, the last test tube, after it's completely heated, you can see that there's a complete color change. You have on the left side your mixture, your compound, and then on the right side you have your individual elements. So here you have a little pool of mercury. So liquid mercury came out of the solid substance. Interesting. So here's the mechanism how it works. You have your HGO, your AB. When the HGO breaks down, it forms Hg. All right, liquid plus your O2 gas. So you have your compound, your A, B, all right, and then forming your A and your B, okay? So it's very simple. Then you balance it. You place a 2 here to balance the O's, and then a 2 here to balance your Hg's, okay? Now, electrolysis. This one's really interesting. I like this one. I've done this before in the classroom. And from regular water, you can get a flammable substance. Okay, so water, H2O. Now there's a little E in parentheses. That's meant to be above the arrow. So that's where electrolysis comes in, where you take a minimum of like 9 to 15 volts electricity and you add it to the water, causing the water to break down. So what happens is the H2O forms a H2 gas and an O2 gas. Amazing. Okay, just using some electricity. So you have your A, B compound, all right? Your H and your O is your A and your B, forming your A and your B, okay? So you now have two individual products, okay? And it's simple as that. Then you have to go and balance it, okay, which is not too bad. You always balance the O's. We're always doing O's. Okay, so we're going to place a 2 there to make two O's on the left to match the 2 on the right. Then this also goes to the H, so we have 4 H's, so we're going to place a 2 here. Then it's a balanced equation, okay? So that's electrolysis. So, which product is flammable? Okay, the flammable product is going to be the hydrogen gas. It's flammable, okay, but it does not burn without oxygen. So, the oxygen helps the hydrogen burn. Without oxygen, nothing can burn. Okay, now the last one here is the decomposition of sodium azide, which is basically found in your airbag. Now, sodium azide is Na3N. It's a solid. When NN3 breaks down, it forms its respective elements. It forms your Na and N2. Okay, so you have your I don't know why my little pen's not working right. B down to your A, B. Okay, so you have your metal and then your non-metal compound over here. All right, so that's how they break down. So for this one, you want to balance it. Do your C, your H, your O. No, then go with the next one. I'm just going to choose N. N has 3 on this side. N has 2 on this side, so we're going to use the least multiple of 6, and I'm going to place a 3 there. So now we have 6 N's on the right, and I'm going to place a 2 here, and we have 6 N's on the left. But also the 2 here changes the Na count. All right, so I'm going to place a 2 right here, making the Na2. So there's your balanced equation. And this is very simple, nothing really too difficult about it. There is going to be electron transfer, which we missed, and we're going to go over that down the road. Okay? So you just have to identify the difference between a decomposition and a combination. Okay? All right, guys. Thank you.